Good morning, friends. This is Naga S. Ramat. I am working as assistant professor in the Department of Electronics and Communication Engineering. So we are discussing on embedded system. In the part 1, we discussed what is the definition of embedded system, what are the examples of embedded system, and also what are the main differences between general computing system versus embedded system. In part 2, we discussed the types of embedded system and core of the embedded system and elements of an embedded system. In part 3, we discussed what are the main differences between the RISC processor and CISC processor. In this video, that is part number 4, in this video I am going to explain what are the main differences between the Von Neumann architecture and Harvard architecture. First, we'll see the block diagram of Von Neumann architecture. The Von Neumann architecture mainly consists of three parts. One is called as memory, then CPU, and third one is input-output devices. Here, the single memory consists of both the memory, that is data memory, as well as the code memory. Data and as well as code, that is instructions, will be available in a single memory. So we have the buses. Through the buses, we can fetch the data and as well as code from the single memory. Then the input output devices will be connected to the CPU as well as memory will be connected to the CPU. And if you observe the block diagram of Harvard architecture, here also it consists of three parts: the memory, CPU, then the input output devices. But the main difference is the memory is divided into two parts here. One is the program memory, another one is the data memory. In case of data memory, the data will be stored, and in case of program memory, the instructions will be saved. So here, if you want to fetch the instructions from the memory, we have to go through the instructions memory, and if you want to fetch the data, then you have to go for the data memory. So we have the separate buses will be used to fetch the data as well as program in case of Harvard architecture. So that is the main advantages from the Harvard architecture. To fetch the data and instructions in a single time, we can fetch both instructions as well as data from the memory part. Okay. And if you observe the main differences between Von Neumann and Harvard architecture, the first one is the less space is required in case of Von Neumann architecture. It requires less space to perform the operation, but Harvard architecture requires more space for the operation of the instructions. The second difference, the speed is low. The Von Neumann architecture, the speed of operation is low because here the both data as well as instructions are stored in a single memory. Suppose the CPU wants to fetch the data or fetch the instructions, it requires separate two clock cycles to fetch the data as well as instructions from the single memory. So that is the reason the speed is very less. But in case of Harvard architecture, the speed is more because here we have separate data memory and instruction memory. So in a single time, we can fetch both data as well as instructions by using separate buses in a less time. So that is the advantage of Harvard architecture. That is the reason the speed of the operation will be more. The other difference, the common bus. So in case of Von Neumann architecture, the common bus is used to fetch the data as well as instruction. To fetch the data and instructions, we are using common buses. That is the reason the speed is very less. But in case of Harvard architecture, separate buses are used to fetch the data as well as instructions. The same memory address is used for both the data and instructions. Here in Von Neumann architecture, the same memory address is used for both data as well as instructions store operations. But the memory address is used for the data and as well as instructions in case of Harvard architecture. Two clock cycle is required. As I told you, so to fetch the data and instructions, we have to use separate buses. So it takes a time duration. So in that cases, the number of clock cycle is required to fetch the data from the data memory as well as instructions memory. So it requires 2 clock cycles. But in case of Harvard architecture, the single clock cycle is required to fetch the data or instructions from the separate memory part. That is the advantage of Harvard architecture. Number of clock cycle is required less, the performance level will be more. The performance will be increases because of less number of clock cycle is required to execute the instructions. The instructions and read-write operations cannot be accessed at the same duration from the CPU. The CPU can't access the instructions and read-write operations in the same duration. But in case of Harvard architecture, the instructions and read-write operations can be fetched in the same duration. That is possible by the CPU. The CPU can fetch the instructions and also it performs read-write operation in a same duration. The other difference, the Von Neumann architecture is cheaper compared to the Harvard architecture. The Harvard is very costlier because we have the separate memory in the data memory as well as instructions memory are separated. So that is the reason the costly compared to Von Neumann architecture, Harvard architecture will be the more costlier. The other difference is small computers. That is, Von Neumann architecture is used in the small computers because single memory contains both data and program memory. So to fetch the data and instructions, it takes a time duration. So that is the reason the speed of the operation will be very less. So it will be used in the small computers. But the speed of the operation is more in the Harvard architecture, that will be used in the microcontroller operations. Thank you for watching this video. If you like, please share and subscribe.